So guys, today is the demonstration 2 of our design pattern principle and architecture online training program. What we discussed in yesterday's session. Yesterday we have discussed why software design patterns principles are more important nowadays, right? When we are developing using AI. So from today onwards, we are going to start our syllabus. So basically, I have provided 8 modules, and in each module there are multiple chapters. And today we are going to start our module one, software design foundations. So this module one is all about, right, the basic requirement or the basic concepts which are mandatory to understand the design patterns and architectures. So today what we are going to discuss the introduction part, the chapter one. So total how many chapters we have provided? It's all about 36, yeah, 38 chapters. Yeah, 38 chapters. So we'll start one by one, chapter by chapter, module by module. We are going to cover all the concepts. So today we are going to discuss this chapter one, introduction to software design and the design pattern. So we'll discuss what is software design, right? We'll discuss why software design is important, right? Uh, we'll also discuss what is the meaning of poor software design, how you can overcome that with the software design patterns, what is good code, what is bad code, what is the history of a design pattern, what are the gang of four design patterns versus algorithm framework and libraries. And we'll also discuss the benefit of using design patterns, when to use design pattern, when we should not use design pattern, how you can choose a design pattern, right, as a beginner, right? All these things we are going to discuss in today's session. See, software development is not only about writing the code. Software development is not only about writing the code that produces the expected output. In real project, code keeps changing, requirement keeps changing, new features are added, bugs are fixes, performance are improvement, and more importantly, multiple team member can also going to work on the same project. Program may work perfectly today. Today you wrote the code and it is working absolutely fine. But poor design can make even a small future change difficult and risky. So your application is working as expected today. That doesn't mean it is a good design. The application is designed poorly, in future, a small change can makes you a lot of work to do behind the scene. So good software design help us organize code so that it remains understandable and manageable as the application goes. So as long as the requirements coming, as future changes are coming, if you design it good, you can easily manage them. So design patterns are closely related to software design. They are proven solutions to common design problems that developers face today. So basically, design patterns are nothing but, right, as a software developer, whatever the common problem we are facing on day to day, right? So to solve those common problems, so these are proven solutions. They have trusted solution. They have already verified by multiple senior level developer, and they find that yes, this is the perfect solution for that particular problem. So they do not. The guys remember, design pattern do not give us any ready-made code to copy paste. So don't think that I'm using design pattern means I can copy paste the code. No, absolutely not. They guide us in deciding how classes and objects should be created, organized, and connected. So let us proceed and understand what exactly is software design. If someone asks you, can you please explain me? You are a software engineer. Can you please explain me what do you mean by software design? Can anybody, before I explain, can anybody tell me what is software design? Anyone having any idea? If someone asks you this question in the interview, very basic question, but if someone asks, then what will be your answer? Anyone having any answer? Yes. See, whether whatever the answer you are going to give, right or wrong, that doesn't matter at all. But try to give your suggestion, give your thought process, what you are thinking about software design, right? So
So
why?
it is
Because
like following some principles in order to uh,
Hmm,
create this software or system.
yes. it is exactly something like this, right? Following some principles, some following some pattern, or you can say it is the process of deciding, right? Software design means what? It is the process of designing how different parts of an application should be organized and how they should work together. So it is the thinking. You can consider it is the thought process of a developer, or it is the thinking we do before and while writing the code, so that the application remains clean, understandable, and easier to change. So while developing the application or before developing the application, what we are thinking, right? How should we write the code so that the code becomes understandable, so the code becomes clean, and the code becomes easier to manage. So that thought process is nothing but your software design. So think about a building. So before the construction begin, an architecture decide where rooms, door, window, electrical line, water pipeline should go. Building may still be constructed without a good plan, but future changes becomes much harder. Software is very similar to constructing a building. So in simple word, you can consider software design help us answer questions. What are the questions? Where should the business logic be written? Which class should write perform which responsibility? How should controller services, repository, and models work together? How can we avoid writing the same logic in multiple places? How we can make the application easier to test? How we can add a new feature without breaking the existing features? How we can change one part of the application without breaking the other part? So these are the questions that what as a software designer we need to ask. So if we are getting the answer, means we are right in the right path. If we are not getting answer, and if this is what we are asking and we are not getting in our project, that means our project is not in a good design. So let us try to understand. So let us try to understand. Guys, remember the actual implementation, the program. I'm going to start from chapter number 2, OOPS concept. But for now, what I'm going to make you understand, as this is the introduction class, I'm trying to make you what is a good code, what is bad code, or how you can write. As a beginner, how you are thinking, as an experienced developer, how you are thinking, how you can move your bad code into good code. For all these things, we are going to understand. Let us start with a very poor design in an ASP.NET Core controller. So let assume you are a very beginner and you start developing the application, and how you are developing the application. Let us take an example of an e-commerce application. Suppose we are building an e-commerce web API application where customer is going to place the order. So a beginner, a fresher may put all the order processing logic directly inside the controller because it looks simple at first. For example, this is my controller class. This is my place order method. And within this method, I'm writing every piece of code. So what are the logic I have written? I have validated the request, whatever the data provided, whether the data is correct. I check the product stock, whether whatever the quantity user want to purchase, whether that quantity available in the database. That's what I checked. Then I calculate the discount, right, based on the logic, right, seasonal discount, right, premium customer discount, some other discount. I calculate the discount. Then I save that order into the database. Then I make the payment. After payment is done, I send the confirmation email to the customer, and then I return the response. So if I'm doing all these things here, is this going to work? Yes or no?
No.
Yes.
It will not work. 100% it will work. Is there any problem your application will not work? Why it should not work, first tell me.
But the design is right. Not right.
I'm not talking
I
about the
mean,
design, whether the design is right or wrong, that is a separate part. My question is this code is going to run or not?
yeah, it runs, but we'll have like lot of performance issues.
Yeah, that is fine. But your application will work or not?
Yes, it works.
It works. Right? 100% whatever code we have written here, it is going to work. And this looks may simple from the at the beginning. But this design has a serious problem. What is the problem? The controller is doing too many things. So it will work, but it has some problem. What are the problem? The controller is handling too many things. What are the things? It is handling the HTTP request. It is validating the business rule. It is checking the stock. It is calculating the discount. It is saving the data into the database. It is also processing the payment. It is also sending the confirmation email, and it is also returning the response. As more requirements are added, the controller becomes difficult to understand and maintain. Now let us try to understand why this becomes a problem, right? So now, when the controller becomes too large, yes, the controller is very long controller. The action method is going to contain thousand line of a code. Testing the order logic become difficult. So now, tell me, whatever the order calculation logic, suppose this order set logic and calculate discount, this logic I want to check. I don't want to check this payment confirmation mail. How I can unit test this? Is that possible? Not possible. So unit testing a specific logic is not possible. Why? Because it is mixed with the API. If payment logic change, do I need to change this part? Yes. If email logic change, do I need to change here? Yes. That means I'm changing this action method whenever there is a small change is required. So this is not the right approach, right? Second thing, multiple developer working the same controller may create conflict. So for example, this is one controller, you are working, some other one is working, right? And it is going to be very difficult to handle this kind of a conflict. And a small change becomes risk when it may affect unrelated behavior. So if I'm going to change email functionality. So I have to come here. If I'm going to change payment functionality, I have to come here. If I'm going to change the data access code functionality, so I have to change here. That means what a small change can may affect unrelated behavior. So why unrelated behavior? Because right payment email doesn't have any link with the payment. Payment doesn't have any link with the order processing logic. So anytime I have to do a small change, I have to come here and do the changes, so it might be affect the other unrelated behavior. So what is a better design? So can anybody tell me what is a better design? So from a high level point of view, from the low level point of view, we will discuss. From a high level point of view, what is a better design?
So usually we write business rules in the service layer. It's better if we maintain the layers like the
Yes,
service layer, the accessor layer, and
exactly.
yeah.
Yes.
So we have to
So
write in such a way that when you have to write your HTTP requests in your controller so that it will go to service, and from there it goes to the accessor, and accessor will only be able to communicate with the database. So you
exactly.
don't have
Then-
to, yeah.
Yes. So absolutely correct. So basically, we need to decide what is the responsibility of a controller. Controller responsibility should handle the incoming HTTP request, and it should return the response of what it got from the services. That's it. No other functionality. No, at some higher level you can do the validation, but no business logic, no data access logic, nothing else. It should be moved from this controller to somewhere else. Am I right? So first of all, you need to decide, right? When you are thinking in terms of a designer, you need to think what is the responsibility of a controller. Controller means it should handle the incoming HTTP request. Controller should return the HTTP response, but what HTTP response it is going to return, that will decide controller. How it will decide? Based on the outcome of the service. So it will invoke the service method. Whatever the service method return, accordingly he needs to decide what data to be returned to the client. Am I right? Yes or no? But from a beginner, if you do not have experience, you are just a fresher, just a student, right? You try to write everything within the controller. Even few days session when I'm taking that a full stack, where someone asked me, sir, why you are creating services? Everything you can put inside the controller only. Yes, absolutely fine. But what is the problem? Maintenance problem, right? Dependency issues, right? Managing those code, right? When the application grows, it will be create a serious problem. So now what I need to do, first of all, now the order controller is not going to deal with any business logic. So I'm injecting my order service. So what is this order service? How to create it? Full implementation we'll see, right? Don't worry. So now order controller, right, to this order controller, we inject the order service, and using that order service, we simply call the place order method. So now you can say within this method, right, within this controller action method, there's no business logic. So it will simply receive the request, it will call the order service, Whatever the response order service return, it can simply return. Yes, this method is not absolutely fine because you need to check what is the status. If status is the success, what response to be returned. If I'm getting some error, what response to be get returned. If I'm right, so that condition you can write. But for now, what do you need to think in terms of from the higher level point of view? That controller should not have any business logic, any data access logic, any validation logic. Validation logic, sometimes if it is only related to the incoming data, you can put. But you should not put, right, whether the stock is exist, whether the customer age exist, right, whatever the quantity user selecting, that quantity should be less than the available stock. These validations should not be part of, right, what I can say, this action method. So what type of a validation? The data validation. So data format validation. Suppose you want that items collection to be not run. So that actually that is going to be handled automatically by the API controller, right? So that bad data should be restricted by the API controller. So nowadays we are not writing right model state dot is valid data time is gone. So that is going to handle automatically by the right controller. So validation you can also skip from this one. So whatever all validation you can also place inside the place order method. Clear? Clear? Yes or no? So
Yes, sir.
basically, from this design, you should move these things, right, to a separate class method, right? So you can see, and now you are simply calling. But again, you can see this order service dot place order means what? You have to implement one interface, and within that interface, and you have to implement. For example, I create one interface place order. So within that order service interface, what I'm doing, I'm writing this validate order, check product stock, calculate discount, save order, process payment, send notification, and simply I'm written. So here also, this is not the correct approach because of payment processing, notification sending, this is not the job of a place order. But yes, from the high level point of view, you can think this is the step one. So instead of putting everything in the controller action method, I moved that logic to a separate class. But within this separate class, whatever the logic we have written, again, this is not correct. So what is the correct? We'll step by step, we'll understand why putting this process payments and notification is not the correct approach here. That's what we will also understand. But for now, from the high level point of view, this is better than the previous app. Clear?
Yes, sir.
Anyone having any question? Yes or no? Is that clear to everybody?
Yes.
Okay. Now, why software development or software design is important in application development? See, in the beginning, the application may only have a few pages, the database contain may a few tables, and you are having a few business rules. At that stage, writing everything in one place may seem faster. The problem appears when the application grows. So in this case, you can see writing everything in one place that might be same or that might be good if your application is very small. But real world applications, guys, remember, never or do not remain always small. They change continuously. New features are added, old logic is changes, bugs are fixed, and already I have discussed, right? Multiple developers are going to work on the same code base. Without proper design, the code becomes difficult to understand, dangerous to modify. So a good design helps the application survive these changes, right? So now, let us try to understand with one, right? One example, why software design is important. For example, suppose an application send only email notification today. Later, the client asks for SMS notification. After a few months, they ask for the WhatsApp notification. So from the beginning, what you are writing, you created one method. They ask for the email notification. Right? Okay, let me do this thing. Right. So initially, the client requirement is to send email. So what you done? So you created this one, public send notification and write the string message, right? So whatever the string message, you just change it and you send it. Later, the client asks for SMS notification. After a few months, they ask for WhatsApp notification, right? And what you have done, you have increased one parameter type, and you type something, type email, if type SMS, type WhatsApp. This is what you will do, or what exactly your thought process? Initially, they created one method, only email. You just want to send email. Later, the client decide, okay, I'm not going to send only email based on the type, right? Whatever the user is configured, you can send to email, you can send to SMS, or you can send to WhatsApp message. So what you will do? So then suddenly you can think, okay, let me type, if type equals to email, okay, I will send email. If type equals to SMS, I will send SMS. If type equals to WhatsApp, I will send WhatsApp message. This is what you will think, or what is your thought process? How you can write think in terms of a design? Let's give your input. Is this a good design or bad design? Or is this, first of all, is this whatever we are doing here, is it going to work or not?
Yeah, it will work.
Is this a good design?
Uh,
No.
no,
Then what is the best design here? Why it is not a good design, first of all, tell me.
because every notification type we are having in the single method, and we are deciding uh, uh, logic as per the type wise. So if the number of the notification type increase, we will uh, open this method, and we have to write if else again.
Yes. What is the problem?
Modification required for the existing code.
Yes. Because whenever I want to add or modify any notification, I have to come to this existing code. So if I'm going to do some SMS changes, then why should I come to here? Tomorrow I want to add a new notification type, push notification. Again, I need to come to here. So according to the principle, method are closed for modification, but open for extension, right? So we'll discuss that concept later. So basically, I have to design, right? If you want to modify the logic, that is fine. If you are going to extend, you should not modify this one, close for extension. So basically, if you want to add a new notification type, then you should not change here. If you want to remove a notification type, then you should not come and do modification here, right? If you are typing in like this, every time you need a small change, you have to come here and you have to do the changes. So this is a very, very bad design approach. But if you ask this to any fresher, or right, even those who right, even senior level developer, still they are writing this kind of coding in their project. If you are working with any new project, if you don't have a big experience, right, and if you are a senior level developer and if you do not know the design patterns, then you can go with this ETL pattern. But this is very, very dangerous. So what is the best design pattern? So create a notification sender class, I mean one interface. Now each interface, whatever the notification type they want to send the message, they can inherit from here and they can write the logic. So email notification, sending message, SMS notification, right? Tomorrow you want to integrate WhatsApp notification, create one more class and write the business logic there. That means what? Now each notification class has one clear responsibility. Email logic is one place, SMS logic is one place, WhatsApp logic is going to be in one place. That means now I'm not going to now my send notification method not doing multiple things. It is not doing so here in this case. If you see, the send notification method doing multiple things, sending email, sending SMS, sending WhatsApp messages. But now with this approach, each class is responsible for doing its own responsibility. If I want to modify the email notification, I only need to come to this email notification class. Not, I don't need to modify the SMS sender or something else. Clear? Right? But if I'm creating this one, then how I can use what sender to be used at runtime? That what we are going to discuss practically using some design button called strategy design button or something else is also going to be there. So for now, Instead of writing the logic using EPLs, right, you have to write the logic using this one. But the question is, do I need to always write the logic something like this? So here you need to think in terms of a software designer. If you know, only two types of notifications are there, either email or SMS. No other notifications are there. In future also, there is no chance that any other notification type will come into the picture. In that case, simple if else condition is fine. But if you know that in future more type are coming into the picture, in future some of the changes, some of the type are going to be removed, then in that case, right, or it might be possible that in future I can send code to both notifications, again email as well as SMS, then this code is not work. In that case, this approach is wrong, because if you are writing if and else if, you cannot send message to both email and SMS. Here also, right, you have to write another if else condition, if type equals to SMS or type equals to email, right. I mean that logic you need to manage separately. You need to give type email or SMS one separate type where you need to send both logic. That means that is going to be very complicated. Am I right? Suppose now you tell me, I want to send a notification to both email and SMS. How you can manage that within this notification class? But that what you can easily manage here. Why? You need to register these two and just create an instance of this class, call this method, create an instance of this class, call this method. It's very simple. Now, what are the problem caused by poor software design? So now, instead of understanding that poorly software design are difficult to change, duplicated code, difficult to maintain, difficult to test, and difficult to reuse, right? So now let us try to exactly understand these particular things practically. Suppose I'm saying rigid code, I'm saying, right, duplicate code, I'm saying difficult to maintain, difficult to test. Suddenly, the interviewer might be ask you, can you please elaborate? So you said poor design code, right? Are difficult to change. That difficult to change means you can consider rigid code. So now the interviewer directly asks you, okay, I understand rigid code is nothing but the code that is difficult to change. That means a small change in one requirement may force us to modify several classes or methods. This happens when different part of applications are too tightly connected. So this theoretically is fine. You can understand these theories. Can you please elaborate this practically? How will you explain? Are you getting my question?
Yeah.
You explain that one of the problem of poor software design is the code is difficult to change. Suddenly, the interviewer will ask you, okay, fine, theory is fine. Please elaborate this with one example. How you will elaborate? Let us try to understand. Suppose an application initially supports cash on delivery. So order service, place order, you have written the logic, right? And payment logic goes here. Payment, cash payment of an amount will be collected. Invoice generated, confirmation email sent, and this is the logic you have written. This logic is clear. So here only the cash on delivery option is there. So you have accordingly write the logic, and this is working as expected. Now, this may be fine for a very small application. Later, the client asks to support. Okay, cash on delivery is fine, but now I want to support credit card, UPI, and PayPal. Then what you will do as a beginner? Guys, give your input so that the
Yeah,
session
I'll
will
go
be
to
becoming
the
nice.
service and I will check if and else statement.
So basically, what you will think, okay, if the payment type is cash, then I'm going with the cash on delivery, otherwise credit card, otherwise UPI payment. Or else, right, if PayPal is there, so you can also write another if else statement that is PayPal. This is what you were thinking.
No,
Yes,
that is a bad design. We need to have an interface that like the one you showed.
yeah,
So
that is
placing order will be one of the interface, and you have a interface and different classes for UPI
exactly that
payment, cash on
exactly.
delivery,
So
and all.
yes. So what is the problem here? It is a bad design, but why it is a bad design? That's what I'm asking.
So let's say if some of the numbers are in integer, not decimal,
Mm.
so then that will be a problem. Even a type change will be a problem. And
No,
if
that
there are
is
like another 4 types of orders that gets added, the code will be lengthy and it's not
yes.
easily maintainable. And any change that you make
In
will
case if you
have an
add,
impact on other
Yes. So
places.
basically, the problem what we are discussing here,
difficult to
difficult,
change.
right? A small change in one requirement may force us to modify several classes method. For example, I have to write a small change means what, right? Some logic we have written here, right? And some changes is required, right? Then what you need to do? For example, so there is some changes in a credit card. Then I have to come here and do the changes here. So the order one, but order service is now responsible for processing order, processing different types of payment. If payment requirement keep changing, we must repeatedly modify the order service. This makes code rigid because payment related changes are directly affecting the order service. So basically, right, to point at what you need to remember, so this, if I want to do some changes in the payment related to payment, why order service? What is the better design? The better design is we can separate payment processing from order processing. For example, I create one payment processor, credit card payment processor, UPI payment processor, cash on delivery payment processor, payment, right, cash payment processor, PayPal payment processor, whatever you created. So they are inherited from here. Now your order service is going to use the payment processor instead of handling the payment logic. That means now with this approach, what will happen? Now the payment logic is separate, order processing logic is separate, and again each payment processor is different. Wherever you want to change, you can. So for example, I want to change in credit card. Okay, directly go to the credit card payment processor and do your changes. Now I want to change in UPI payment. Okay, go directly here and right do the changes. So while I'm doing the changes in payment right related activities, my order service is not going to be affected. That means the code is not now rigid code. Rigid code, it means what? Now it is not forcing me to change the order service when I'm doing some changes in the payment service. Clear?
Yes.
Clear or not? So this is what you need to implement. Duplicate logic, right? So duplicate logic means what? Duplicate logic means what? The second problem of a bad software design is duplicate logic. Duplicate logic means the same or similar code is written in multiple places. So multiple places means what? That's fine. So as a beginner, right, what you can think, okay, sir, I can do copy and paste. I know what is control C and control right B. So I can copy and paste wherever I want to copy, I can control C and control V. And this looks faster initially, right? But it creates maintenance problem, right? So now tell me what is the problem? Suppose an application gives a 10% discount. The developer write the calculation logic in order service, right? So you can say, this is my order service. While placing the order, I calculate the discount. Again, I'm having the invoice service where also I need to calculate the discount. I'm writing the same logic. I'm having the card service. Again, I'm writing the same logic. And you told that, "Oh, sir, it's fine. I write here and then I just control C and here control V and here control V and it is working absolutely fine. And 100% it is going to work absolutely fine. But what is the problem? The problem is maintenance problem. Everything work correctly while the discount remains 10%. Now, suppose the business changes the discount from 10 to 15%. Then what you need to do? You need to update the order service. Yes. You need to update the invoice service. Yes. You need to update the card service. Yes. For example, one developer forget to update the card service. Then what will happen? A different part of the application will calculate a different discount. Am I right? Yes or no?
Yes.
Yeah.
Right. Then what is the better design? Better design is keep the discount calculation logic in one reusable class. For example, I create a discount service class. So here you can also create this method as a static method if possible. And actually it is you need to create this method as a static method, right? So that you can use this class name and this method name and call that reusable logic. So now this method will contain my discount logic. Now from the order service, I inject the discount service instance and call the discount. And if it is changed from 10 to 15, only I need to update here. And the same approach you can use, right? The same approach you can use in card service, you can use in inventory service. So wherever this logic is required, just inject the service and invoke the method. So with this approach, what I can do is what is happening is that logic is reused. If you are repeating the same logic at multiple places, then please try to avoid the same. Create reusable classes and call them wherever it is possible. Clear?
Yeah.
Clear or not? So this
Yes.
is the second design issue that what you need to identify. As I'm showing some basic design issues, the real implementation, the use of all the design patterns, what design problems they are going to face, we'll discuss. Why I'm showing, giving this simple examples, because you can easily understand, right? And once you start implementing the design patterns, all the principles and architecture, at that time you will get more clarity. So difficult in maintenance. Maintenance means what, guys? Maintenance means working with an existing application after it is already developed. So, for example, one project is developed, you join a company and you are going to work on that existing project. Existing project means what? Maintenance only. Maintenance means what? Now you can fix the bug, you can change the business rule, you can add some new features, you can improve some existing feature, you can remove some old feature, you can improve the performance, and you can improve the security, right? Improving security. So these are the things that what comes as part of maintaining the project, right? In real world project, a developer spend a large amount of time modifying the existing applications, right? Consider this example. Suppose this is my place order method where I'm validating the order, I'm checking the stock, I'm calculating the discount, I'm processing the payment, I'm saving the order, generating the invoice, and I'm sending the email. At first, this code looks very simple, but now how many responsibility this order services have? Multiple responsibility. So inventory, validation, discount payment, or everything is part of this order service. Suppose the client asks us to change only the invoice generation logic. We still need to open and modify the order service. If the payment logic changes, we again need to modify the order service. If notification logic changes, we again modify the same class. As more responsibilities are added, this class becomes larger, and once the class becomes larger, it is very hard to understand and perform the unit testing. What is the better approach? So better approach is create one inventory service related to the stock check, create one stock check, stock updated, right? Whatever the product right, verify whether the product exists. You need to update the product stock quantity. So that logic will come here. Payment service, creating the payment, then doing the making the payment to if it is online payment, go to PG, whatever the response, then update the payment details. Inventory invoice service, sending the invoice. Email service, right? Invoice means it generate the invoice so that the PDF can be visible in the UI. Also, that PDF, right, that email service can send to the customer email address. So basically, what I'm doing here, I'm creating separate classes as per their right responsibility. Now, what the order service will do, it will take the required service instances, right, through the dependency injection, right, we can inject the services. What is dependency injection? We'll see in detail how the services are registered, how the service instance are created, how the framework is going to inject the instances, what is the lifetime of the instances. We'll see all these things in dependency injection. Now from this method, I can call the inventory check, process payment, then I can set the order. This is part of order. Then I can call the generate invoice, and then I can call the send email. So now each responsibility has a clear location. Clear location means each responsibility has been defined in a separate class. If invoice logic changes, then you can go to the invite service class, not to this order service. If payment logic changes, you need to go to the payment service class, not to this order service. If email logic changes, again, you need to go to the email service class, not to this order service class. This makes the application easier to understand and maintain. So good maintenance become easier when each class has a clear and focused responsibility, right? And anyone who is having solid responsibility, solid design principle knowledge, right? One of the principle is SRP, single responsibility principle, right? Can anybody tell me what is the meaning of a single responsibility principle?
Single purpose, single achievement.
Yeah, single responsibility. Yeah, okay, tell me. Suppose if I'm creating a class, does single responsibility means that class going to have only one method or it can have a multiple method?
One
It can
process
have
like that
multiple.
for employee having like that pay bonus and payroll means we can move to payroll is a separate logic, separate class like that.
Yeah. For example, I'm having the inventory. So let's take this example, inventory. So in inventory, in inventory service, so this is my stock, check stock. Can I write one method, update stock here within this inventory service? This is one class. Currently, it is having the stock check responsibility. Can I add another method here, update stock?
Oh,
Yes,
yes.
sir.
Yes,
Yes.
we can.
Right? Stock update. So basically, single responsibility principle means what? Single responsibility principle means it doesn't have the class having only one method. So single responsibility principle means the class can have responsibility or responsibilities if they are related. So updating stock, checking stock, both are related only. Both are related to stock. That is the reason why I can put both. But this inventory service and payment service, I cannot put here payment method. Why? Because payment is a different, inventory is different. So the point that what remember, single responsibility principle doesn't mean the class can have only a single method. It can have multiple methods if those methods are related to each other, related to that particular responsibility. So here, checking stock, updating stock. So both are related to stock only. So I can put both method within this inventory service class. Clear?
Yes, sir.
Yes.
Yes. So this is my payment service. This is my invoice service. So accordingly, it is going to process this one. Okay, fine. So now the next part, what we are going to discuss is difficult in testing. So before understanding this one, first of all, I will ask you the question: what do we mean by unit testing?
To check the whatever we have implemented is working correct or not.
Whatever means what?
What are the
The
functionalities we have created?
Any simple small business logic that needs to be unit tested, right? Whatever the small or whatever the smallest business logic we have written, that we need to unit test independently. For example, I'm having a controller, I'm having a service, and I'm having a repository. So I need to check the controller logic without depending or without executing the service logic and the repository. If I want to test the service, then I want to execute the service logic only without to executing the repository. That means unit testing means independently. If the class depends on external dependencies, they should not be executed. So we need to create some mock object. Now, tell me, in this case, the way we have written this code, inventory service, payment service, right? It's a email service, that is fine. But now tell me, so in this case, right, let us try to understand. So this is my email service. This email service having this method send email. And now this order service, what exactly it is doing? It is creating an instance of an email service and it is calling that send email method. So with this logic, is there anything wrong? So I'm having a separate class and I'm using that send email method to execute that logic. Later, if I want to change the email logic, I can come here. But is there any problem with this design?
It is tightly coupled to one email service. If tomorrow I want any other service, then again I'll have to go to the service class to change the both the unit test as well as the main
Yes.
service logic.
So basically, the point that what you need to remember, whenever you are creating an instance using this particular, right, this particular new keyword, it is dangerous. So now if you look at the order service, it is creating the email service instance using this new keyword. So with this new keyword, what is the problem? Problem is the code, this order service and this email service is now tightly coupled. So once the code is tightly coupled, what is the problem? One problem is unit testing is difficult. And what is the other problem? If that service have multiple implementations, you cannot use them. I mean, you cannot provide multiple solutions. We'll discuss that one. And for example, generate a report. So if you want, you can generate report in PDF, you can report in Excel, you can generate a report in Word, right? So if I'm creating that generate report instance directly here, I cannot give multiple solutions. So that is separate story altogether. Now we are going to keep focus on the unit testing. So when a class, when the dependency object is created by the class itself using the new keyword, then unit testing is difficult. Now, tell me why unit testing is going to be difficult in this case. Understanding unit testing is difficult, that is fine, but how? Why the unit testing is become difficult, particularly in this scenario? That's what I need to understand. Can anybody tell me?
Maybe
Yeah.
if the source email service is changed, maybe one method or something, maybe we need
No,
to retest it again and again.
no, that is
So
not the correct answer.
it is going to validate place order logic as well as the email sending logic.
Exactly. So basically, what is the meaning of a unit testing? So I'm saying unit testing means testing the independent logic. For example, if I'm in testing this place order logic means what? Only the logic written here needs to be tested, not the logic written within the send email method. Whether the email sending functionality is working or not. That's what I can write some unit test for this method. But when I'm testing this place order logic, at this time, how can I create a fake object of this email sender? Because the instance is created directly. Directly means what? If I'm executing this method, 100% whatever the logic is written here, that is going to be executed. So instead of executing this email service, how I can create a fake instance of the email service, and how I can ensure that my order service would use that fake email service instance. That is not possible when you are using this new email service. So basically, the point that what you need to remember, you should never create the instances using the new keyword directly within the class itself. Always go with the right what approach, interface based approach, right? Let us try to understand. Suppose I create an email service instance, sorry, interface. This email service interface implemented by this email service class. Now the order service is not creating an instance of this class and it is injecting that instance through the constructor. Now the place order logic method is going to send the email. So here, what is the difference? Earlier, I'm creating that instance within the class, and now what I'm doing, I'm injecting that instance through the constructor. So with this logic, unit testing is becomes very easy. So how it is going to become very easy? Let us try to observe. Suppose with this approach, what will happen? Now, right when you are going to perform the unit testing, you need to create an instance of this order service class, and you can invoke this method. So now, as this is interface based, so can I create an fake email service inheriting from this one? So here you have written the actual emails and functionality. But now what I'm going to do, I'm going to create a fake email service. And here I'm not writing any logic and I'm simply writing email sent to true. This fake email service I have, now what I can do is I can create, so while I'm going to do the unit testing for the order service, I can create a fake email service instance. I can pass that fake email service instance to this order service, and the order service thus place order method is going to invoke. So when this method is invoked, so this fake message is going to be displayed. Clear or not? So this fake instance I'm creating and passing to this order service only because of this approach, this good design. So creating an interface, implementing that one, and most importantly, your class should accept that object as a parameter. So whatever the object we pass, that object it will use to call this method. Earlier, what is happening? Earlier, whatever the logic we have written here, that is always going to be executed. But with this logic, now we can decide from where that email send functionality, from which instance that send email functionality should execute. Clear? Yes or no?
Yes, sir.
Yes, yes.
So this is the reason why unit testing also going to be difficult if your design is not good. So what is dependency injection? All these things we'll discuss. Low reusability. So low reusability means what? Reusability means writing useful logic once and using it in multiple places. Poorly designed application often places useful logic directly inside the controller and method, making that logic difficult to reuse. Let us understand this. For example, this is my order request. Suppose there are two approaches. One approach is you can create an order right from the user can place order. Also, you are providing that option that an admin panel or some internal member, and they can also create the order from different screen. So let assume this order controller creating the order, right? And here what you have written that logic, if quantity is less than zero, if product ID is less than zero, then it is going to return this logic and it is going to return this logic. So this is the some of the logic you have written, right? For the validating the order requested data. And that is absolutely fine. But what happened? This validation 100% is going to work. But what happened if this validation logic you need at multiple places? If this validation you need at multiple places, then how you can reuse this thing? If you are writing this logic directly here, can you reuse this logic in some other places? No. You have to copy paste this. Copy pasting is very dangerous in software development. Then what is the best approach? Can anybody tell me?
Business logic should not present in controller side.
See, this is not business logic. This is what I can tell from the beginning. Yes, controller can have some data validation, and this is data validation. You can place this simple validation. Not, I'm saying whether the product exists in the database or not, whether the customer exists in the database, that validation should not be part of your right the controller. But whatever the data, and you know the quantity must be greater than zero. If quantity is greater than zero, then only I can proceed. Product ID should be greater than zero. If product ID less than zero, why should I make a call to the database to check whether the product exists or not? So this validation, if you want, you can keep inside the controller, absolutely fine. Clear? What is the problem
Yeah.
with this logic? Any better approach? If the same logic I required in another controller, if the same logic I need in another service class, then how you can do this thing?
You can create separate class, then you can call it inside the controller.
Yes. Right. So better approach, create one order validator. This order validator having this each valid method. Whatever the order request you pass, it is going to check, right, boolean false, right? If any validation is false, it is going to return false. If all the validation are passed, it is going to return true. Now, can I use this order validator instead of handling this logic directly? Yes. How? Let us do. Suppose this is my order controller, right? To this order controller, I inject my order validator. And simply order validator that is valid. If data is valid, that is fine. Otherwise, it is going to return this error. Now, some other order admin service, some other place is there, right? You want to use this one. So here you can see again I'm passing this order validator, creating an instance of order validator, and here I'm checking whether the order is valid or not. The same logic I have written here. So with this approach, right, your validation logic is going to be at one place, and the same validation logic is going to be used at multiple places. Why I'm saying this? This is a very common scenario I see. Many of the developers they have written this logic. If you need to validate this logic at the controller level, if you want to validate this logic right at the some other places, some services, some other places, how you can do this thing? So you can create a validator class. Clear?
Yes, sir.
Right. So in simple word, what is a rigid code? Rigid code means a small change require changes in many places. Duplicate means the same business logic is copied into multiple classes and methods. Difficult means classes contain too many responsibility and become difficult to modify. Unit testing means dependencies cannot be easily replaced with fake or mock implementations. Low reusability means useful logic is tied to one place and cannot be reused. So these are the different things that what we have practically discussed. How what is the problem and how we can overcome that problem using good design part. Clear? Is that clear,
Yes, sir.
guys?
Yes.
Okay. Now we need to understand what are design. Just give me 1 minute. Okay. What are design patterns? We have already discussed design patterns are proven solutions to common software design problems. They are not ready-made code that we can copy and paste. They are not libraries, packages, or framework. Then what are they? They are reusable ideas, reusable design ideas that help us in organizing classes, organizing object, organizing responsibilities, and organizing communication. So basically, how you can better organize the classes, object, responsibility, and communication. That helps, right? They're going to give you some idea. If you follow that idea in your project development, definitely it is going to organize your classes, object, responsibility, and communication better. A design pattern gives us a general structure for solving a problem, all right, for solving a particular type of design problem. It gives us a tested approach. That approach is already tested. But the exact implementation depends on the application language framework. See, the design patterns, what I'm going to discuss, they are not going to be, right? They are not going to give any copy paste code. They're giving some ideas. And that ideas, how you are going to implement, that is going to vary based on the application, based on the language you use. For example, if you are using if you are using ASP.NET Core framework, so the dependency injection design pattern they have implemented in their own way. If you are using Spring, they have implemented in another way. For example, if you are using C Sharp language, you can write code C Sharp according to the C Sharp syntax. It might be different in Java, but the principle, the ideas, the whatever they have provided, that what you need to follow. So implementation that might be vary based on the framework language, but the concept is going to be same. So what exactly it means? It means design patterns are not related to C Sharp or Java or Python. They are common, they are standard solutions. And every language and framework they have implemented in their own way. Clear?
Yes.
Clear? Right?
Yeah.
Some of the common design problem, right? Why design patterns are introduced? Let us try to see. How can we select one behavior from many available behaviors? Suppose I want to, right, what I can say, multiple payment options are there. Which payment options to be used at runtime? So how we can select that behavior? So how we can create an object without tight coupling code to concrete classes? Instead of creating that dependency object using the new keyword, how I can inject that object so that my code becomes loosely coupled? How I can add extra behavior without modifying the existing code? So basically, right, one pattern is a decorator pattern. So one existing class is that, but to that existing class, I want to add some more behavior, right? Some right, extra behavior. How I can do this thing, right? How I can notify multiple object when something changes. For example, if you see, right, what I can say, observer pattern. So if you see that Amazon website, so when one product is not available, they have provided one option, notify me. And like once you click on the notify, like you, so many people say, click on that button. And when that product available, right, they send a notification to all the members how it is implemented, right? So that what you can use something called observer pattern. So how I can modify simple access to a complex subsystem. For example, right, for example, you are having one right place order functionality. That place order is going to contain some multiple steps. So instead of calling those steps one by one, so you can create a simple subsystem, call that subsystem. That subsystem will handle executing the logic properly, right? So how you can reduce repeated conditional logic, right? So instead of writing if else code again and again, how we can create that logic in a better manner. And some of the important pattern, right? Not important. Some of the pattern are strategy pattern, factory pattern, decorator, observer, set pattern, right? So these are the pattern, right? They are going to give some of the commonly solutions, right? What are these pattern? How to implement each pattern? We'll discuss in detail. Clear, right?
Yeah.
Suppose this is what one problem. For example, right, what I can say, notify multiple. So I have given. So how you can add extra behavior. For example, right, reduce the repeated. For example, simplify. So everything is going to be right implemented with real-time scenarios. I'm going to show you how you can decide, yes, this is the problem. For this problem, this is the solution. Everything I'm going to show you practically. And at the end of right, each session, you will understand what is the use of that particular design pattern, how you can implement that design pattern, and most importantly, you can take the decision. Decision taking, right, taking is very, very important. Now, why design patterns were introduced? See, design patterns were introduced because the developer around the world repeatedly face similar design problems, right? Doesn't matter whether the developer belong to Java, belong to .NET, or belong to some other uh, language or framework. So repeatedly they face some similar problem. And irrespective of the domain, so it doesn't matter whether the domain is banking, e-commerce, education, healthcare, wholesale, insurance, trading, whatever may be the right domain, the problem are going to be similar. What experienced developer notice that some solution work well again and again for a particular problem, that solution is working as expected again and again. So instead of solving the same problem from the beginning every time, those proven approaches are documented and shared as a design patterns. So typical problems, right? For example, how do you create objects without tight coupling code to concrete classes? How do you change behavior at runtime? How we avoid right large if else condition block? How you can make code extensible without modifying the existing classes? How you can simplify complex subsystems? How you can allow object to communicate without depending directly on each other? So these are some of the common problem for this. For each common problem, they figure out yes, this solution is working. So okay, let us document the solution as a design pattern. So design patterns are not random theory. They come from practical software development experience. They are useful because they teach us how experienced developer solved common design problems in a reusable way. So basically, um, right, what happened while developing the problem project, irrespective of the domain, irrespective of the framework language, some common problems, right, are appear, and they figure out here for that particular common problem, that solution is working again and again. So then what they thought, okay, if this solution is working again and again for a particular problem, let us document that solution and call that solution as a design pattern. Clear?
Yes.
Clear? Okay.
Yeah.
The history. See, the most famous object-oriented design patterns were introduced in the book Design Patterns, Elements of a Reusable Object-Oriented Software. This is one of the book, and this book contains the most of the design pattern. This book was written by four authors, so you can see, right? These are the four authors who have written this book. These methods are popularly known as a Gangopur or GOF. And the GOF book introduced 23 classical object-oriented design patterns, right? These patterns are categorized into three categories. One is creational patterns. These creational patterns is deal with the object creation. So how effectively you can create an object that this pattern explain. Structural pattern is to deal with the class and object composition, how you can create an instance right within another class. And the behavioral pattern is basically for the communication and responsibility between objects. How one object communicate with another object, how you can differentiate the responsibility, right? At what it is related to this one. So we'll discuss this creational pattern, structural pattern, and the behavioral pattern in detail. So we'll see what is object composition, right? What is object communication, what is object creation, right? All these things we are going to discuss in detail. So now we need to understand, right? People are thinking that the design pattern, algorithm, framework, library is there. So guys, remember design patterns, algorithm, framework, library, and software architecture doesn't same thing, right? They are not the same. They are different. So what is an algorithm? Algorithm tells us how to perform a calculation or process data. A framework gives us a structure and tools for building an application. A library provides us reusable functionality that our application can call. Architecture defines the high-level structure of the complete application, and a design pattern gives us a proven way to organize classes and objects to solve a common design problem. So this is the right definition, but generally definition will not give you clarity. To get the clarity, what we actually need, we need example or real-time scenarios. Let us try to understand the difference between a design pattern and the algorithm. So design pattern and algorithm are not same. We already discussed an algorithm is a step-by-step procedure for solving a specific problem. Algorithms are commonly used for tasks such as sorting data, searching for an item, calculating discount, calculating tasks, encrypting data, many whatever functionality you are implementing, for that you need one algorithm. For example, right? For example, let's assume suppose an application gives customer a 10% discount. So this is calculate discount, and here you have written the logic. The above code describe how the discount is calculated. If the amount is 100, the method calculate the discount as 10 into 10%, that is 100. This is the calculation logic. So this is the calculation logic. This calculation logic is nothing but your algorithm. Right now. Now suppose our application support different discount rule. So different discount rule means what? Now regular customer discount, premium customer discount, a festival discount. The beginner, right? As a beginner, what we generally write, we write everything here. Right? Customer type is regular, give 5%. Premium customer, give 15%. Festival discount, give 20%. If none of this, return 0. So generally, you have written this thing. And here, the calculations are still algorithms and business rules. So whatever the calculation we have written here, this is nothing but your algorithm. But as more discount types are added, this method can become difficult to maintain. Here we can take a design decision to separate each rule. So for example, I can create a discount strategy, regular discount inherited from here, implement that logic. So here this logic, whatever we have written, this is algorithm. Here this is algorithm. This is algorithm. But the approach what we applied here, right, creating an interface, creating multiple classes, inheriting from the discount, this is nothing but the design pattern. So this class follows the basic idea of strategy design pattern. The important difference is the multiplication used to calculate the discount is the calculation logic. So the multiplication what we applied here to calculate, so that is nothing but your calculation logic, and that calculation logic is nothing but your algorithm. The decision to organize a different discount rule as separate interchangeable classes is a design decision. So design decision. So what you need to understand is an algorithm tells us how to perform a task or how to do a calculation. Algorithm tells us how we can perform a task, how we can calculate the discount, how we can implement sorting, how we can implement paging. That is algorithm. A design pattern tells us how to organize the code to solve a recurring problem. So basically, if tomorrow I want to introduce one more discount type, how I can solve that effectively. That is where design pattern coming into the picture. Is that clear? What is design pattern and what is algorithm? Is both are same or both are different? Is that clear?
Yes.
Right. So this is our algorithm and how we are implementing, how we are solving this common recurring problem, that is design part. Now, the next question, we need to understand design pattern versus framework. We already know framework provides a ready-made structure and a set of tools for building application. The popular .NET framework are ASP.NET Core MVC, ASP.NET Core Web API, Blazor, WPF, .NET MOE. So these are different kind of right, what I can say, framework. For example, if I'm creating a application, right, using MVC or Web API, let us assume a Web API, it provide features. What are the features it provide? Now it provide features to create a controller. It provide features to handle HTTP requests, routing, dependency injection, configuration, authentication, authorization, middleware, model binding. Many features are provided by this Web API framework. So let us try to observe. Right? For example, we create this controller, API controller route inherited from the controller base HTTP GET. So now tell me, this API controller, this route attribute, this controller base class, this HTTP GET method, who provided these things? It is provided by framework or we are creating this one?
Provided by framework.
Framework.
So basically here, this controller base, API controller route, HTTP GET, action result are provided by ASP.NET Core. We do not need to build the HTTP processing infrastructure ourselves. Framework gives us the structure and runtime support. Clear? So if someone asks you what is a framework, you can explain this thing, right? Framework means it is providing a set of tools or set of structure for building the application. If you take the example of Web API controller, in Web API controller, we create a controller inherited from the controller base class. We can use action result return type. We can use HTTP get put patch delete method. We can decorate our controller with API controller. We can make use of route attribute. So this API controller route controller base HTTP get, these are the tools which is provided by framework. We are not in building that infrastructure. That infrastructure for developing the application is provided by framework. Now, a design pattern, right? For example, on the other hand, design pattern is not a software that needs to be installed. So it is an idea or you can say proven approach for organizing our code. For example, suppose a service needs to send a notification. So you can create I notification, send method, email notification, right? Now the order controller is making use of this service. So basically, ASP.NET Core can provide the required implementation through its dependency injection, right? For example, here you can see. So suppose I'm using this order controller. In order controller, I'm injecting this one, this notification service. But this notification service is going to work when we register this I notification and email notification service to the dependency injection container. Here, ASP.NET Core is the framework. The use of abstraction such as notification service is part of our software design. So this is part of our software design. ASP.NET Core is the framework. ASP.NET Core dependency injection system helps connect the implementation at runtime. So this is provided by framework, and this helps us to connect that actual implementation at runtime. So in very simple word, what you can see, a framework gives us infrastructure and the structure for building and running the applications, while a design pattern gives us guidance for organizing part of our code. Clear? So design
Yes.
pattern means organizing of our code. Framework means it is providing the infrastructure and the structure. Infrastructure and structure both are different. Infrastructure means how you can develop and how you can run. Structure means what is the structure. Controller is there. Controller needs to be some action method. That structure is also provided by framework. Now, design pattern versus libraries. See, these are very simple thing, but it needs to be very clear from the beginning, right? Suppose a library, what is a library? A library is a collection of a reusable code that perform one or more specific tasks, right? For example, our application calls the library whenever it needs the functionality. For example, NuGet is there. You can install Newton subtraction. You can install Serilog. If you want to go with the Automapper, you can also install Mapper, Mapperly, you can go with the Dapper, you can go with the Fluent Validation, right? So many packages are provided by, right, what I can say, .NET framework, or you can say these are nothing but .NET libraries. For example, suppose you want to serialize this JSON C# object into JSON object. So using Newton soft.json, you can create your .NET object and you can call this serialized object by passing this product, which is going to return you the JSON I mean that JSON string. So here, this JSON.serialized object, right, is the functionality provided by Newton soft.json library. Suppose another example, you are using logging, log dot information. So here it is logging. Serilog provides the logging functionality. So a design pattern is different. So this is nothing but you can consider library. Library provides a reusable code that perform one or more action or some specific task. So here one library is JSON.NET, and here when I'm calling this method, it is performing some action. When I'm calling this method, it is performing some action. A design pattern is different. We do not install a strategy pattern or factory pattern using NuGet. So don't consider that a singleton strategy factory we are going to install using NuGet. No. Instead, we implement the pattern through our classes and the interfaces. So this is my interface, this is one class, this is one class, and this is how we implement. This is a design pattern, and these are the libraries which is provided by framework, which we can use to perform some operations. Clear? Clear or not?
Yes.
Is that clear?
Yes.
Okay. Now we need to understand when to use design pattern and when we should not use design pattern. See, use a design pattern when it solves a real problem and makes the code easier to understand, easy to change, and easy to extend. It should not make the code unnecessarily complex. Right? A design pattern is useful when the code is becoming difficult to change. You see large or repeated if else or switch block. You see object creation is becoming complicated. You need multiple implementations of the same behavior. You want to reduce tight coupling between classes. You want to make unit testing easier by depending on abstractions. You need to know, you need to add a new behavior without repeatedly modifying the stable code. The pattern, right, makes the design clearer instead of more complicated. Simple example, multiple discount payment rules. Okay, go with the strategy pattern. Complex object creation, go with the factory or builder pattern. Logging, caching, validation around an existing service, go with the decorator pattern. A complex subsystem need a simpler entry point, go with the facade pattern. Object, right, one object needs to notify many subscriber, go with the observer pattern. Some of the example I have provided, but guys remember, each design pattern is going to solve a particular problem. If Django 4 provided us 23 classical design pattern, that means 23 recurring problem they are going to solve. Some of the problem I have highlighted here, 5, 6, and the remaining every problem I'm going to discuss as part of this training program. Then when not to use the design pattern. So design pattern should not be used everywhere. Sometimes, right, a simple method or a class is the best solution. So avoid a pattern when the problem is simple and unlike change. The pattern add more unnecessary complexity than the value. The code becomes harder to read after applying the pattern. A simple method or class is enough. You are using the design pattern only because you recently learned it. The patterns create many interfaces and classes without a real need. So if this is what you are getting, then don't go with the design pattern. Beginners, right? How a beginner friendly when to think about the design pattern. Beginner often ask, how do I know whether my design is good? See, there's no single formula, but a few simple questions can guide you. So ask these questions while designing the code. So does this class have one clear responsibility? Is this method doing too many unrelated tasks? Am I writing the same logic in multiple places? Will this code be easy to change when a requirement changes? Can I test this class without using a real email database or payment services? Am I depending directly on a concrete class when an interface would provide useful? Am I adding unnecessary interfaces or patterns to a simple problem? Will another developer understand this code after reading it? Ask this question. If you are getting the answer, that's fine. If you're not getting this answer, does this class have one responsibility? No, it is doing multiple responsibility. Okay, I need to go with one design pattern. Is this method doing too many unrelated tasks? Yes, it is doing. Okay, I need to figure out the design pattern. Am I write the same logic in multiple places? Yes, I'm writing. Okay, I need to go with a design pattern. Accordingly, you need to ask this question to yourself, and and accordingly you can decide whether you need to go with the design pattern. So do this class of one clear responsibility? Yes, it is having only one responsibility. Absolutely fine. So simple design improvement checklist, right? Keep controller focused on HTTP request and responses. Separate validation, separate business logic, separate data access, and separate external service logic. Avoid very large method with many unrelated conditions. Move shared logic into reusable service instead of copying it. Use interface when you need multiple implementation, flexibility, and textability. Use meaningful class and method name. Apply design pattern only when it solves a real problem. So these are the things that what you need to figure out, you need to ask, you need to check before applying a design pattern. So with this guys, this is our demo session 2. Tomorrow we are going to start discussing the OOPS concept, right? I will discuss the OOPS concept in detail, right? Everything I'm going to cover. That object-oriented programming, first of all, I will explain, right? With the concept first. First of all, I will explain the concept, layman example, concept, what is this, why this, right? What is the problem, what problem it is actually solving, all those concepts I will show you with sample code. And then I'm going to implement the same by taking one real-time application. Because, right, understanding the concept is fine until and unless we have not implemented that concept in real-time application, and until and unless we have not understand how each concept are implemented in that application, you will not get the clarity. So we'll develop one real-time application using .NET 10. So guys, remember I'm going to use .NET 10 for this training program, and I'm going to create a multiple class, right? For example, for understanding OOPS concept, I'm going to create a 6-7 tables, and completely using entity framework core, I'm going to explain the OOPS concept. For example, I'm creating this product class. So how this product class uses the OOPS concept, that's what I'm going to discuss, right? So similarly, every concept I'm going to show you by taking by implementing that practically, you will get the clarity. So that's what I'm going to discuss in the next 2 sessions. So first of all, I will discuss the OOPS concept in detail, right? And then I'm going to discuss, right, encapsulation, how it is being implemented from a layman analogy, how you can implement it from the real-time e-commerce application, some sample code to implement encapsulation. That's what I'm going to explain. Practical implementation in the next chapter, right? So when I'm implementing that e-commerce application completely, at that time I will explain you how encapsulation is implemented, how abstraction is implemented, right? So that you will get the clarity. Clear? Clear, guys?
Yes.
Right? So everything, right? By taking the layman example, you can easily understand. Also, I'm going to give you, right, how you can implement from e-commerce or real-time applications. I'm going to show you the sample code, how it is going to be implemented. Next, I'm going to implement the complete application in front of you so that you can understand the OOPS concept clearly. And this is very, very important. See, these design patterns, whatever we are going to learn, it is based on the object-oriented programming only. So if you understand the object-oriented programming perfectly, then understanding the design pattern is not a big deal. So, so how easily you are going to understand, or how easily you are going to learn the design patterns, that basically depends on how strong you are into OOPS concept. So that is the reason why I'm going to start with the OOPS concept. So first of all, I will explain OOPS concept. Then I'm going to implement the example. Every chapter, right? Whatever I'm going to discuss, the pattern is going to be same. Pattern is going to be same means what? First of all, I will make you understand the concept. Then, for example, this is object. So I will make you understand the concept one real-time application. Then in Solid, I will make you understand all the Solid design principle, list of ops, right, open, closed, single responsibility interface, TIP. Then I'm going to implement a complete application using these principles. Similarly, dependency injection and inversion of control. I'm also going to show you the concept first. I'm going to implement a real-time application so that you can understand this. Similarly, unit testing, I'm going to show you how you can use unit testing to test individual controller services, repositories. That's what I'm going to show you. So once this module 1 is completed, then I'm going to start module 2. And module 2 means some basic fundamental layered architecture. What is layered architecture? Right? What is MVC design pattern? Right? And what is options pattern, which is very frequently used. So once this is done, then only I'm going to start our design pattern sessions. Right? Because I'm going to show you example using MVC application, using web API application. So I will also make you understand what is MVC application, the architecture, what are the things they have implemented, how to develop the application. Web API also the architecture I'm going to explain. Right? Also one of the pattern that is very frequently used in MVC and web API, that is options pattern. So that's what I'm going to also discuss. So once this is done, then we will start our design pattern from module 3. Clear? Now, if anyone joined for the first time today, right, I would recommend watch the previous session. And I'm also going to share today's session, right, and the documents. And also, if they are having any question, any queries, they can ask me. Let me stop the recording.